Hey friends, we're back for the second lesson in our final unit, probability. Before we start the second lesson, I'm just going to go back and I'm going to finish the summary that was at the end of your practice from the previous lesson because some of that stuff's going to help us with today's lesson. Okay, here we go. So from the last little mini lesson you did, it was a pretty short one, right? What we want to do here is we just want to go back over and talk about a couple of really important things. Okay, first thing. Probability we're going to write as a fraction or as a decimal. It is really important that if there are no rounding instructions, do not round. So if I was given a fraction like, I don't know, 3/7. 3/7 is approximately equal to 0.42857 dot, 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 dot. Okay. I would prefer that you did not round this or truncate this, meaning just leave it as a fraction. If you are going to leave it as a decimal, I want 4 decimal spots. That is important. That popped up on the diploma a couple of years ago, and kids lost some very easy marks for being silly. Okay, experimental probability is found by performing an experiment and can change with each trial. Theoretical probability is determined by, I don't know, math and thinking. I don't know. I typed that. I don't even know what I want to say. And does not change. An event is considered fair if all outcomes are equally likely. Think of flipping a coin here. Probability should be thought of as a fraction or as a decimal if I'm given rounding instructions, or if it terminates. Any probability will have a value between 0 and 1. That's 0% and 100%, meaning it's impossible or it's certain. It has to happen. Okay, I am certain, a 1, that I'm about to continue to the next page. Okay, next little mini lesson here in this unit. It's a short one, but it's, again, things that you've probably dealt with, but it's just needs a little formalizing. So again, we've got this student rolling a standard die again. I have to say standard because that's 1 to 6 sides. There's different types of dice in the world. So list all the possible outcomes. Okay, sample space. Hey, didn't we do sample spaces and counting methods? Determine the probability a student receives a 3 on the roll of a die. So that's P3. Well, there's 6 outcomes, and there's only 1 outcome I want, a 3. Determine the probability the student does not receive a 3. Well, I could do P not 3 and count all the ways that I don't get a 3, 5/6, or I could be a math ninja and use the complement, which tells me if I want P not 3, that's equal to all other options, well, 100% of the other options, minus the probability of getting a 3. So 1 minus 1/6, and guess what? 5/6. So the complement is still going to be something that we might want to consider. So 2 different ways to get the answer there. And then from last class or from last lesson, whenever you were looking at this, there is how we define probability. What's new today is working with odds. We see odds a lot in real life. A lot of times we see it, like I always think of the Stampede lotteries or Stars home lotteries, and they talk about odds. And I honestly think they use odds in these because people don't actually understand what odds mean or how they work. And you'll see what I mean here when we get going. So in odds, we're really going to express our odds using as a ratio using the little colon symbol here. So odds in favor of an event occurring. It's the number of ways I get what I want. So it's the number that I want versus the number that I don't want. Okay, or you could call this the number in favor to the number not in favor. Okay, so determine the odds that a student receives a 3 on a roll. So how many ways can I get a 3? 1. How many ways can I not get a 3? 5. So that's the odds in favor that a student receives a 3. Do you notice the difference between that and the probability of getting a 3? Probability of getting a 3 is 1 over 6. So the one big difference here is probability. This is the total number of outcomes possible. In odds, I don't see the total. To get the total, I have to add these together to say there's 6 outcomes. Now, what I'm going to really suggest you do here to make your life, I don't know if it makes it a lot easier, but I found that it helps students not make mistakes. I'm just going to clear what I just did there. Is I'm going to, maybe let's just look at E. I'm going to ask you to do this. Keeps it easy. It says determine the odds a student does not receive a 3. What I'm going to do is, a friend of mine one time I was up marking and she said she does the FAT method. And I said, okay, what the heck are you talking about? She said, I do this and my kids always get it right. She said, they nail these questions. Okay, so what she says, she goes, she gets her kids to write down FAT every single time. So F, favor, in favor of. A, not in favor, is also known as against. And T is total. So for, against, total. Well, it's a die, so there's 6 in total. I do not want a 3. There's 5 ways I cannot get a 3. And there's 1 way that I can get a 3, odds against. Notice the 5 plus the 1 add to the 6. I love it. So odds against, so I want not 3 to getting a 3. So that would be 5 to 1. Determine the probability a student receives a 3 on a roll. So P3. Again, if I go back and I look at my little FAT thing that I write down here, or if I maybe do it again on this question. So F, A, T. This time, odds in favor is getting a 3. There's 1 way to do it. Odds against getting a 3, there's 5 ways. And total, 6. So the probability that I receive a 3 is 1 over 6. Like it. So the big difference between odds is that we don't see the total here. The total's not shown. Okay, I'm going to show you in just a minute why, again, I think people are confused with odds, and why, honestly, I think when you're talking about lotteries and things that they use odds, because people don't really understand how to convert from odds to probability. So in a children's card game, one player has all the hearts of a standard deck, so that's 13 cards. And the other player must choose one of these cards. Determine the odds in favor of choosing a face card. So it says write out all the outcomes. I could certainly write out all the outcomes. So I've got the ace, the 2, the 3, the 4, dot, dot, dot. Jack, queen, king. Write out all the favorable outcomes. Okie dokie. Well, it says I want a face card. So my favorable outcomes, I'll call them F, is Jack, queen, king. All my not favorable, I'm going to call against, because it's what I don't want. Well, it's everything else, right? Now, do I really need to write those out? No. But does it hurt me? No. It's never a bad thing to do. D, here we start getting into the questions that you'll see on tests. Determine the odds of choosing a face card. So I'm just going to write down off to the side here, F-A-T. I want a face card. So that's my favorable outcomes. There's 3 of them. Against my unfavorable, well, there's 10 of them. Total, there's 13. So the odds of choosing a face card, 3, 2, 10. Just like that. So see when we've got this little FAT thing written down here, how handy it actually is. Determine the probability of choosing a face card. Okay, so P face, what I want, 3 over the total amount, 3 over 13. Do you notice if I asked you to go from odds in favor to probability in favor, that you would need to add the 3 and the 10 to get that 13 there? Okay, this is what I mean. I think when people think odds, they actually think odds and probability are the same thing. So the really wrong thing here to do is to say, they give you the odds. They say the odds of winning are 3 to 10. And what people do then is they say, oh, okay, if that's my odds of winning, they think this, 3 over 10. When really we know the answer is 3 over 13. Well, if you compare these two, the wrong way to do it makes you think you have a better chance, a better probability of winning. I honestly think that's why companies use odds when they're promoting things instead of probability, because people honestly don't understand. Sneaky, sneaky. Okay. What do we got here? Gordy has 5 coins in his pocket. 3 of these coins are quarters. He reaches into his pocket and pulls out 1 coin at random. Determine the probability that the coin is a quarter. Okay, so F-A-T. Total, well, there's 5 coins. 3 of these are quarters. That's my favorable. So that means there's 2 that are not quarter. That's my against. Determine the probability of the quarter. P quarter. 3 over 5. Odds that the coin's a quarter. So that's quarter to not a quarter. So that's 3 to 2. And determine the odds that the coin is not a quarter. Well, now all I need to do is just simply flip this one. 2 to 3. Not a quarter to a quarter. Now, I find it really helpful if on a test you write these statements. Here's why. If you write that statement, I know what you're doing, or at least what you're trying to do. So if you did screw it up, at least I can give you part marks. If you don't write that, so say down here you didn't write not a quarter to a quarter, and for some reason you wrote 1 to 4, I have no idea what you're trying to do. Okay, I can't help you. Can't give you any marks. So if you always express what you're doing, it's better. Make it clearer for the person marking. Again, it's not all about the diploma, but I'll tell you when I'm up marking diplomas, how many kids don't write things down and how many easy marks they lose because they're not expressing to us what they're trying to do. Okay. A recent study found that the probability of obtaining a university degree is 1 over 5. So, F-A-T. Total, 5. Favorable, 1. 4 against. So determine the odds in obtaining a degree. Oh, why is there a question mark there? And there. All right, guess what? I got to fix when this is done. Okay? So, odds in favor. So this would be degree to not degree, which is 1 to 4. Okay, what's the odds against obtaining a degree? Well, that's odds against, so all I need to do is flip this. Not a degree to a There it is. Okay, so again, look at how once we write this little FAT thing, this FAT method down, just how quick and easy it is to find these odds and these probabilities. Okay, almost there, my friends. Okay, back in the day when I was a kid, it was very common when you bought a pop bottle, or you bought a pop, inside the top of the bottle was a little plastic thing, and you would flip it over and it would tell you if you won a prize or not. Okay, so back in the day, you could win like a Super Nintendo and get Super Mario, which was the best thing in the history of video games ever. So Pepsi, who I worked for way too long, has a win a free bottle inside the bottle cap. The odds against, now I've bolded the word against there. It will not be bolded on your test or your diploma. You need to watch for it and maybe highlight it. Determine the probability that I will be a winner. Okay. So FAT. So this is odds against. So the odds against me winning. So there's 57 ways I don't win. There's 43 ways then I do win, and I add those together. 43 plus 57 is 100. So what's the probability that I am a winner? Well, 43 over 100. Leave it like that, or because this thing does terminate, you could write it like that. Never, ever, ever this. No bueno, okay? I will not be happy with you. Alrighty, so when we're finding the probability again, you need to make sure that you're finding that total by adding those two numbers together. Okay, in the Italian card game Scopa and Briscola, okay, so Scopa is like Italian Go Fish. Briscola is like bridge, where you play with partners. And you've actually got these super cool Italian deck of cards. They look very different than ours. The odds against, so there it is again, when a player doesn't have the first term, are 5 to 2 and 7 to 3 respectively. Which game gives the player the best chance to win if they do not have the first term? Okay, so what do we got here? We got Scopa, we got Briscola, and I'm going to do my FAT. I'm never going to decide who has the best probability of winning from odds. I'm always going to do it from probability. So it says the odds against the player winning. So 5 to 2. So that means there's 2 ways that I would win, 5 ways that I wouldn't win. Total is 7. Briscola. It's the odds against. So that means there's 3 ways that I would win, 7 that I wouldn't, 10 in total. So now what I'm going to do is, now that I know the odds, and I can write the probability. The probability I win for Scopa would be 2 out of 7. The probability I win for Briscola is 3 out of 10. And now, if I want to turn these into decimals, what I'm going to see, I mean, I know this one here is 0.3, and Scopa is about, again, this is why I don't like rounding, but I'll truncate right there. It's about 0.29. Okay, so which game has the better chances of me winning? If I don't have the first term, Briscola. Okay, box your answer and maybe write me a sentence. Briscola better yo. Okay. That's a good question. If you just followed along with that and you're like, yeah, Sally Annie, I got that, then you are rocking this thing. Okay. Last question, I think. Odds of winning on a certain scratch game. Now, you're not 18, so you shouldn't be addicted to scratch games yet. Back in the day, the rules were a little bit more lax about kids playing these games. But you guys should not be playing them as of yet, I certainly hope. Okay, So it says the odds of winning a certain scratch game are 3 to 10. So that's the odds in favor. Lottery decides that for the holidays, what they're going to do is they're going to double the probability. Whoa, super nice guys, eh? Determine the probability a person who purchases this scratch card gets a winner during the holidays. Okay, so right now, FAT, it says the probability I win. Well, the odds I win, I should be careful there, right? Because that's what people think it means, it's the odds. So right now, the probability I win is 3 over 13. Okay, the wrong thing, again, wrong, I'll just write it down. People generally would say that it's 3 over 10 or 30% chance of winning. You're talking to someone like, I got a 30% chance of winning. No, you don't. You don't at all. Then you can say, you didn't take 30-2, did you? And they tell you probably to shut up, but you can learn them something important. The actual probability you win is, I'm going to round it here, or truncate it, I should say, is that. So it's actually about 23%. So now, these super nice lottery people, there's never nice lottery people, so this would never happen, by the way, right? I've never heard this. So what they say is, hey, they're going to double this. Well, if I'm going to double the chances that you win, I'm going to multiply this by 2. So I get 0.4615, or I would actually prefer 6 over 13. Okay, that is my new probability. Now, if the probability you won on a scratch card was almost 50%, I think they probably wouldn't be happy. They wouldn't be making a lot of money. But never forget, the house always wins. It's a little bit under 50%, so they're still going to make some money, but not a ton. Okay, if you followed along that one, put a huge star beside that one. That is a super bueno question. Seen that on diplomas lots. Okay, the last thing I want to look at here is number 7. I'm going to skip number 8. If you look at number 8, the only reason I leave it in the book is because my diagram is so pretty and I'm so proud of it. A restaurant offers Chinese, Thai, and Korean food. Give you a little hint for life. If anyone ever offers you, a restaurant says they're going to offer you Chinese, Thai, Korean, and they also sell hamburgers and French fries, you should run for the hills. It's not going to be good. Let's go back up to here. Hey, there's 28 students in Mr. Connolly's math class. I wish there was 28 kids in my class. Hey, wouldn't that be awesome? Number of students in the yearbook club and the number of students on student council are to the right. Hey, it's a Venn diagram. So here's where we start linking our units together. Determine the odds a student in the class is in the yearbook club. Well, yearbook club is this whole circle up here. So again, I'm going to go and highlight it. That's this right here. My highlighter didn't. That's that right there. So how many people are in yearbook? 7. How many people are not in yearbook? Well, that's everyone else. Well, a lot of people just say, hey, there's only one other person there. No. How many people are in the class? There's 28 people in the class. So what are we missing? Well, we're missing the fact that there's 20 people out here, right? That aren't doing anything, slackers. So really what you got here is 7 to 21. There's 7 yearbook people to 21 not in yearbook. Alrighty, determine the odds a student is in the yearbook club or on student council. Okay, like it. So I'm just going to switch to pretty orange. Here's my highlighter. Well, remember, or is the 2 sets put together, isn't it? So yearbook club or student council to not yearbook club or student council. Well, how many ways can I be on yearbook and student council? 8. How many can I not? Well, that's that 20. That's these slackers out here. Now, for both of these answers, if you look at them, 7 to 21 and 8 to 20, I'm happy with both those answers. I truly am. But you can actually reduce both of these. You see on A, you can divide them both by 7. And on B, you can divide them both by 4. Okay, I'm happy with both of these answers. However, I am warning you that on most multiple choice exams, because when we write these questions for your diploma, we're jerks, guess what we're going to do? We're going to reduce them. So that's an extra little step I want you to consider. Okay, determine the odds a student is in yearbook club and on student council, also known as our intersection, right? So that would be this region right there. Okay, no problem. So I'm on both. That would be 2 to 26, yearbook club and student council, to not yearbook club and student council. And do you notice you could also reduce that if you so chose to 1 over 13. Okay, last one. Determine the odds a student is not on yearbook club or on student council. Okay, well, that is the negation of this one. So all I need to do is simply flip it. 5 to 2. There we go, my friends. Okay, I'm not going to do the last one, like I said, for the reasons that it's going to give you a stomach ache. I'm just leaving it because I'm so proud of my pretty picture. You have no idea how super proud I am of making things like that, because I'm a huge nerd. I wish I could print your books in color for you, but that would cost way too much. Okay, I digress. Here's your summary. Odds are a different way to express the likelihood of an event occurring using a ratio with our colon symbol here. Odds are written as the number of favorable outcomes to not favorable, or you could say 4 to against. The total number of outcomes can be found from an odds ratio. This is really important right here, by adding the favorable and the not favorable. The biggest difference between probability and odds, and this is where people, I think in real life, like I explained, screw this up, is the total is not in the ratio. So one last example of that. If I told you the odds in favor of something happening were 3 to 10, the probability then would be 3 over 13, not 3 over 10. That's no bueno. That's really wrong. Okay, so look at that. I can put a stamp on these things. How cool is that? I'm learning as I go. So those are your two big ones that I'm going to put a star beside. Maybe I'll put a heart beside it too. It's such a lovely thing. Okay, friends, there it is. One more lesson for you in the books. I hope that was okay. Go ahead, try your little practice here. It won't take you too long, and I'll see you in our next lesson. Take care.